Hello students, now we are going to describe more about dielectrics. Generally, a non-conducting medium or insulator is called a dielectrics. Precisely the non-conducting materials in which induced charges are produced on their faces for the application of electric fields are called dielectrics. For example, air, hydrogen gas, glass, mica, paraffin, wax, transformer oil, etc. These are the examples of dielectrics. Now, polarization of dielectrics. Now, we know that dielectrics substances are two types, one polar and second one is non-polar. Now, we are talking more about the non-polar because we already discussed more about polar molecules. When a non-polar dielectric slab is subjected to an electric field, then dipoles are induced due to separation of effective positive and negative centers. It means, suppose that this is a medium in which dielectrics are placed and they are non-polar. Non-polar means their positive and negative charge centers coincide. Okay, all the molecule of the dielectric have a spherical symmetry and the positive and negative charges are coinciding each other. When by some means if we produced here a positive charge and here a negative charge, then there is a electric field induced. Then with the help of this field, the positive charge center and negative charge center of the molecule separated. Okay, separation produces the net dipole moment for the molecule. So, when a non-polar dielectric slab is subjected to an electric field, dipoles are induced because initially all the positive and negative charges are coinciding each other. So, net dipole moment is 0 and no dipole are formed. But when there is an electric field, then due to inducement, the positive and negative charge centers separated each other and there is a small dipole formed. The formation of the dipole increases or enhanced. So, there is a net dipole moment created for each molecule and hence the net molecule containing per unit volume also possesses a net dipole moment. Here E0 is the field applied and we are seeing that all the positive charges of the molecule are acting downward and the negative charges is lying on rightward, left upside. Then the field created by the inducement of the charges charging centers or positive and negative charge centers is acting upward. Okay. Now, the net field E net can be defined as, because we know that the direction of the applied field is downward and the field of the produced due to the polarization is upward. So, net field can be expressed as a E0, that is applied field, minus EP, that is field produced or induced. So, field is reduced when the dielectric slab is induced. It means when an dielectric slab is introduced between the plates of the capacitor, then the net field inside the capacitor decreases. Okay, the dielectric constant is given by suppose that if we have the value of E0 and EP, then we can easily solve the what will be the dielectric constant or relative permittivity of the medium or dielectric, that can be expressed as E naught upon E naught minus EP. Okay, this is a simple formula by which we can easily find out what is the relative permittivity of the dielectric slab or the dielectric constant of the dielectric slab. Now, what is polarization vector? The polarization vector means the degree of polarization of the dielectric. If suppose that N is the number of atoms or molecules per unit volume of the dielectric, then polarization vector can be defined as n multiplied by the electric dipole moment of one molecule. That is, capital P equal to is n multiplied by small p. Small p is the dipole moment possessed by one molecule, and capital EP is the polarization possessed by per unit molecule, per unit volume molecule. SI unit of the polarization vector can be defined as coulomb per meter square. Okay, dielectrics and polarization vector and polarization of dielectrics. Tomorrow we will discuss the polarizing strength and the what happen when a dielectric slab is placed between the capacitors. Then what will be the effect on the capacitance? We will discuss it tomorrow. Okay, thank you.